Andy，可以给我 permission share screen 吗？Good morning, guys. Let's get started. Today we'll continue to talk about while loop, and we're finishing while loop, the part about while loop. So let's have a quick recap on what we have talked about previously. So here previously we talked about switch, right? So switch is something for switch structure is something like if else structure. So sometimes switch structure make your code a bit more cleaner. So there's a sample here. So switch and then a sign will be a character type variable. And then based on the type of this sign based on the value of this sign, like if the value is plus, then we can execute something. If the value is minus, then we execute something else. And remember to put a break statement here. The break statement is so that after your case is fully executed, it will next break out of this switch statement. And then there would be a default case. So default case is for like when all the above cases doesn't match, then we will execute the default case. And after the default case is fully executed, it will break out of this switch statements. And then we talk about loop as well. We talk about for loop. So this is a sample of for loop. There's some styling issue here. Here's a sample of for loop. So first, we write a keyword for, and then open the parenthesis and close the parenthesis. And then there are three parts inside this. Inside this parenthesis, there are three parts. The first part is for you to initialize your variable, your counting variable. And then the second part is your looping condition. So this condition calculated into true or false. if it calculated into true, then we're going to run this statement. This statement will be run. If this condition calculated into false, then we won't run this statement and it breaks out of this for loop. Okay. And then the third part is the control, is for the control of the variable. So usually it's like I plus plus, I minus minus, I plus equal 2, I plus equal 3, something like that. For controlling the variable and to control how many times our loop will happen. This is something like a simple sample. So for integer I equal to 0 and while I is lesser than n, always run this loop, and every time after these statements are executed, I plus plus. So you can see that this loop will be run n times from I equal to 0 to I equal to n minus 1. So this loop will be executed for exactly n times. And then we talk about break as well. Break is also a special keyword for loop and while loop. So for switch, for loop, and while loop. So inside this for loop, if you add a break statement, it will break out of the for structure entirely and it will execute the statement after the for structure. So let's look at an example. An example here. Maybe not here. Maybe we'll see it later in this chapter. Okay, and then let's continue to talk about while loop. So when should we use while loop? When we need to loop something right. We want to execute something for many times, then we use while loop. But then it's very similar to for loop. The idea of it is very similar. But then in later part, we'll have a tips on when should we use while loop and when should we use for loop. In which situation while loop is a better choice than for loop. Okay. So this is a flow chart of while loop. First, we entering the while. When we first entering the while loop, immediately, instantly, we go execute statement. There is no conditional checking first. Oh, sorry, there is a conditional checking. So when we first enter while loop, immediately there is a conditional checking. So if this condition is true, then we execute a statement. And then and after a statement is run, we go back to a condition checking part. If the condition is still true, then we loop again until when the condition is false, then we quit the while loop. So this is how while works. So it's highlighted in red. First, when we enter, we check the condition. And then if true, execute your statements and go back to this condition step. And then if it is false, exit the while loop. While is like a continuous looping process. As long as the conditions are met, it will keep repeating. So as long as this condition is calculated into true, as long as it is true, then it will keep executing a statement here. So this is a sample of our loop. It's a very common structure. First, remember inside while you write a opening and closing parenthesis, right? And then inside a parenthesis, it should be the condition. So for example, usually a condition is something we calculated. It's a calculated condition. For example, n lesser than 10. So here there's an n, right? So of course you have to define it somewhere. You have to declare it and initialize it. So where can you do so? You can do it above, right? Above the while loop. Before you execute the while loop, you have to declare n and then you initialize it. So we declare n as an integer and then we initialize it as 0. And then here it says, while n is less than 10, we are always going to execute. We're going to print out hello. So that means we are going to print out hello for like 10 times. Every time after this is printed out, these statements are executed, we are going to execute n plus plus as well. So that we can control how many times this while loop loops. So in this case, every time when you loop n plus 1. So that means this will loop for like 10 times. So here it says, first step, declare a counter variable and define the initial value. So we declare n and we initialize it as 0. And then, while this condition is true, execute the instructions inside the curly braces. So here, the instructions are to print out hello and to increase n by 1. And curly braces, here's a tips. Curly braces are used for storing the executable statements. So if you have multiple statements inside your while loop, be sure to wrap it around a pair of curly braces. And then there is a counter. Our counter n, right? Remember to change it, to update it. So every time while the loop runs, we increase it by 1. So it's used for, the counter is used to control the loop's termination condition. If not set up properly, it can result in an infinite loop. That means your while will always be run and never break out. And the consequences is that our program keep running and use up a lot of CPU because it keeps looping. So it's a very bad thing. We need to avoid to have an infinite loop. So make sure to set your counter properly. And it's the same for loop. So in your for loop, also make sure to set it properly. Otherwise, it would be possible to have infinite loop. So the execution flow is demonstrated here. So first, n is 0 and n is less than 10 is true. So we're going to print out hello. And then after hello is printed out, now n plus plus, right? After n plus plus, n equals, and now it's equal to 1. And the second round, n is equal to 1. And n is still less than 10. So print out hello again, and n plus plus, now n is 2. So we go on and on until n equal 9. When n equal to 9, n is less than 10, and we print out hello, and we n plus plus, and now n equal to 10. When n equal to 10, next round, n is not less than 10 anymore. So this condition is false. If this condition is false, then we're going to jump out of this while loop and execute the statement below it. Okay. So also last week we saw a little bit about the debugging, right? So let me demonstrate it again for while loop. Let's say we have a integer n equals 0 while n less than 10 prints out this n n plus plus. Otherwise, print out while loop ended. Start debugging. So now, initially n is 0. Okay. And then we're going to step over. Step over means going to next line. So we're going into next line. So n is 0, right? So n is lesser than 10. That's why this is being executed. Step over. So if we go to input, debug console, step over. And then n plus plus. The next line is to execute n plus plus. Step over again. Now n is 1. And then 1 is still lesser than 10. So if we step over, still this will be executed. And now n is 2. And we keep stepping over until n equal 9. Now n is 9. Okay, and if 9 is still less than 10, so it's still going to execute the statements inside. So hello world and then n plus plus. After n plus plus, n will be 10. 10 is not lesser than 10, see? N is 10, right? 10 is not lesser than 10, so the next line would be while loop ended. So we already step out of this while loop. The while loop ended. Okay. Yeah, this is what is being printed out. Hello world, hello world. Hello world will be printed out for 10 times, and then while loop ended will be printed out, and then everything ended. It's very important to have the skill to debug. So especially the step-by-step debug. So try to play with it yourself. So sometimes if you face some issue, right, and you really don't know what's happening, you can try to feed it into this kind of online IDE and try debug it step by step. And then there is a question about while loop. We'll go through it later in the homework session. So this is another sample to loop through. Wait, the previous one is to loop through. Something I loop through 1 to 10 is super simple. This question is to loop through to print out 197 until 2. It's quite simple also. This is a similar one. And next we are going to talk about break. So break is something I'm sure you guys have seen it already in switch statement. So break out of your switch control structure. So in for loop and while loop, it's similar. Break play a similar role. It's for breaking out for your for loop or while loop. So yeah, so there is a note here. Break is for immediately break out of the most recent for or while loop. For example, let's say we have this sample. So integer I equals 0. While I less than 10, you're going to do something. Okay. So what is the something here? If I equal to 7, we're going to break. And then I plus plus. And then C out. And then we print out I. So what will happen here? Let's go through it step by step. First, starting from I equal to 0. And then as long as I less than 10, the content of the while loop will be executed. So we're going to execute. And after each execution, the I will be incremented by 1. Okay. It will exit the while when I equal to 7. Then it will see out the I. And what will be the number of I? What will be this I when we print out this I? Would it be 7 or would it be 8? Yeah, this is the question. Will I plus plus be executed? When we break out, will I plus plus be executed? What will be I? We can try it out by ourselves. So here, if n equal to 7, break. And then we print out n. Let's run until n equal to 7. Now n is 6. Okay, now n is 7. 7 is less than 10. So go inside the while loop. And if n equal to 7, break. So let's click on it, step forward. Break. Immediately it breaks out of the while loop. It doesn't execute the line below it. So that means 7 will be printed out instead of 8. Yeah, 7 will be printed out. Okay, as you can see, break immediately breaks out of the while loop. And it's the same for loop. Inside a for loop, if you write a break, immediately it breaks out from the for loop. So remember, while loop is interchangeable with for loop, right? So we can change this thing into for loop. We can rewrite our for loop into our while loop into a for loop. How can we do so? So here for integer. So for initialize the n to 0 first, and then the condition is n less than 10, right? So right, the second part is condition. Condition is less than 10. So remember to separate it by a semicolon between these three parts inside a parenthesis. And then the third part is to control your counting variable. It's n plus plus here. It's the n plus plus. And then inside for loop, if n equal to 7, break. And then let's run this. So it prints out 7. It's the behavior is exactly the same as for while loop. Immediately it breaks. So there's a question here. Design a program where the user repeatedly inputs an integer n until integer is a multiple of 7. Oh, okay. I think we go through this question last week, but no worries, we'll go through it again later. And then there is something about break syntax as well in the exercise section. Okay, next we'll talk about a special keyword. This special keyword is called continue. So it's like break is for switch, for and while structure, right? So this continue is for and while structure only. So what it does, let's look. Continue to the next iteration of the loop and start from the head of the loop. So this continue means whenever we meet this continue, we're not going to execute any code below it. We're going to start over this loop. You're going to the first line of this loop again to check a condition and then to start executing from the beginning again. So in certain specific situations, you may want to skip this iteration of the loop. That means you may want to skip the execution below, the codes below the continue code. So this continue statement, skip the remaining code below and go to the beginning of the loop. Where is the beginning of the loop? The beginning of the loop is this while true. So we will need, when we go back to the beginning of the loop, we will need to check the condition again. Okay. It will not end the loop. The ending of the loop depends on this condition, right? So there are two ways to end the loop. Either this condition calculated into false, or if there is a break statement. If there is a break statement, it breaks out of this while loop. While this continues serve different purpose, it goes back to the first line of the code. It doesn't break the loop. So there's a sample here. So we have a for loop. So inside this for loop, we are saying that so we look from I equal to 0 to 5. And we are saying that if I is 3, continue. That means we are always going to print out I except when I equal to 3. Because if I equal to 3, we are not going to print out I. We're going to loop through this for again. So the output will be 0, 1, 2, 4. Why? Because when I equal to 3, the code doesn't execute the below part, the bottom part of these statements. So continue to skip this round and go to the head of the loop for the next round. Let's try it by ourselves. So for n equal to 0 to 5. If n equal to 3, continue. Otherwise, print out n. There's a syntax error over here. CL was not declared. So it's inside a namespace std. So if you don't want to write this std, it's tedious for you, you can say using namespace std. And then here you don't have to refer it by std anymore. Run again. Click on debug. And start. So step over. N is 0, right? N is not equal to 3. So we're going to print out n. N is 1. Next, n is 2. Next, now n is 3, right? If n is 3, n equal to 3, continue. That means we won't execute this line. We'll directly go back to line 14. Let's observe it next. Yeah, directly go back to line 14. So 3 will not be printed out here. 3 will not be printed out. So 4 will be printed out, and 5 won't be printed out because 5 is not less than 5. So it ends the loop. And continue. So what is being printed out is 0, 1, 2, 4. So this is the usage of for loop. It goes back to the top of the loop. And what if we change this continue? Okay, before that, let's demonstrate it on while loop as well. Let's demonstrate it on while loop as well. So in our while loop, if n equal to 3, continue. Or n less than 5. If n equal to 3, continue. Okay, let's debug this. Step over, print out n plus plus. Now n is 1. Goes until n is 3. Now n is 3. n equal to 3, continue. That means we're going back to the first line of the loop. The first line of the loop is line 18. So line 18, yeah, we goes back to line 18. And next n equal to, oh, still next n is equal to 3. Why? Because this n plus plus is not being executed, right? So we have an infinite loop here. Because n is never changing, so this will always be executed. This loop is an infinite loop. So how can we solve this issue? So can add an additional step here. If we found that n is 3, remember, right before we continue, n plus plus, and then continue. So let's try it again. Start, step over. So step over until n equal to 3. Now n is 3, right? n plus plus, n equal to 4 now. And continue, going back to our first line. So our first line is line 18. Now n is 4. Print out 4, n plus plus, n is 5. 5 is not less than 5. So, okay. So it prints out 0, 1, 2, 4. As you can see, sometimes the control structure in while can be a bit more troublesome than for loop, right? But still, sometimes using while loop is a better choice. I think we will see it later in one of these slides. And then, so continue to skip this round and go to the head of the loop for the next round. And then how about break? What if we change the continue into break? What would happen? If we change the continue into break will, remember, break will break out of the loop. So immediately we go to the end of the loop. We go to the next line after the for structure. So here we goes to return 0 if it is a break. And then there's a question here. Use for loop to show numbers below from 1 to 98. We'll go through it later. So we'll go through it later as well in the exercise session. So in what condition is better to use while loop? So there's some tips here. Which one should I choose? When you have fixed number of repeats, like when you know you're going to repeat the loop for 10 times, for 1,000 times, or 1,000,000 times, and it's fixed and limited, then it's better to use for loop. But if the number of repeats is unknown, you don't know how many times you are going to run this loop, or the condition is unknown, you don't know, you're not exactly sure in what kind of condition you should run this loop, then you should choose while loop. So maybe I think there would be some example in our homework session, and you will see that sometimes it's just really better to use while loop. It's just not a wise choice to use for loop. Okay. So, but first, what does fixed number of repeat means? For example, it's like fixed number of repeat is like this. Yeah. Something like this code. This is fixed number of repeats. Already we know we are going to repeat it for 5 times. So we look from n equal 0 to 5, right? It's fixed and it's limited as well. So Yeah, it's fixed and limited in this case. But in some other cases where you're not actually exactly sure what to put over here, then maybe it's better to use a while loop. Like you're not sure about the condition. If you're not sure about a condition, you can just maybe you should use while. Why? In while you can make it true here, and then you make your condition inside. How you make your condition inside? So it's like if something happen, we break, right? It's similar to condition. Condition helps you to break out of the loop. So this break statement helps you to break out of the loop as well. So you can tell this while loop to always execute. And then the condition checking will be inside your logic. Inside your logic, you explicitly control when should we break out of this while loop, when should we continue, something like that. So if you are not sure about this part, the conditional part, then it's better to use while loop. The code will look cleaner. So this is about choosing between for loop and while loop, and we'll see them more in the homework session. Okay, this is another sample. It's telling that design a program that can determine if a number is even by using a while loop to allow for repeated input. When the user inputs 0, the program should terminate. Okay, that means we always allow the user to enter something until the user inputs 0. So this is an example of unknown number of repeats. We don't know how many times it will repeat because it will always repeat until the user inputs 0. Then the program terminates. And then, so this is a conditionally number of repeats. We don't exactly know how many times it will repeat. And then, so we can use a while loop. And inside the while loop, when we see that user is entering 0, we write a break statement, right, to break out of the while loop. So this is one of the use case of while loop. 3 steps. First, we need to prepare logic first. The logic is you need to define a number, and then we read the number from the input. So we read a number, and we're going to check whether the number is an even number here. The requirement is for determine if a number is even. So here we determine if a number is even. How can we do so? Can make use of the percentage, the modular expression, or the modular calculation. That means if it's calculated to 0, that means it's a multiply of 2. So this number will be even. So if the number is even, we're going to print out true. Otherwise, else, we're going to print out false. And then we wanna let user to keep entering number, right? So we can put this inside a while loop. So this loops again and again. And the condition for the while loop will be true so that it always run. But then this is an infinite loop, right? An example of infinite loop. It's not good. Infinite loop is bad. So we want to somehow, based on the condition, we write some condition inside. Based on the condition, we wanna break out of this while loop. Okay, how can we do so? So we can add a checking here. So every time inside a while loop, we read in a number from input. Right after we read in the number, we can check. If this number equal to 0, then break, right? That means breakout of this while loop, because if number is 0, we're going to terminate this program as a whole. So can set a break statement here. Yeah, so this is it. And also, not just that, you see there's if, else. Actually, we can merge these two if. So if, and then there would be an else if. Right, an else if here. So if number equals 0, do something else. If number is an even number, do something else. Else, otherwise, print out false. That means it's not an even number. But either way works. Either this is a separate if, or we make it else if. Either way work. But what's the difference between this double if and else if? There's some difference between double if and else if. Let's try let's demonstrate. Let's demonstrate it. Let's say n equal to 10. If n equal to 2, out. And if n equal to 3 to 10, also print out n. And then debug it. Start. So if n equal to 2, print out something. It's not equal to true, right? So you're going to the next line. Now you're checking if n equal to 10, going to n. Not, yeah, it's true. So you're going to print out n. Okay, but what's the difference between if and else if? If we change this, it looks very normal, right? But if we change this into else if, what will happen? So if n equal to true, step forward. Else if it's not equal to 2, so we're going to check whether n equal to 10. Else if n equal to 10, print out. So 10 will be printed out. It looks the same so far, but what if? So double if and if else if looks the same so far, but what if? So let's say this is a 10 here, there's a 2 here. Debug it again. See, here, if first time we check, if n equal to 10 is true, right? We're going to execute this. And then the next line will be line 19. It doesn't go through the else if condition. If the if condition is matched, after this logic, these statements for this condition is executed directly, it breaks out of the is else case. So it going to the line 19. So it's different from double if. If you have a double if, we try to debug it. If you have a double if, first, if this condition is fulfilled and we printed out and still next is going to execute line 18, is going to check again if n is equal to 2. If it is equal to 2, print out something. Okay. So as you can see, I hope you get the point. That means if and else if you return your code as if, or you return your code as if, else if, have a little bit of the logic difference. So be sure of what kind of logic that what logic exactly do you want? You want some kind of logic like this, like if you match any of the cases above, ignore all the cases below. Or you want something like this, we want to check all the cases regardless whether the above matches or not. So this is some think about if else that you need to care about, you need to think about when you are writing your code. So, okay, let's continue as an application of loop. Logical control and planning is important in designing a code. Efficient use of loop is crucial for program optimization. Now, design a program where users can repeatedly input a positive integer, determine whether number is composite number, and display a corresponding result as true or false. Enter 0 to any program. Wait, what does composite number means? So if it is 19, false. If it is 91, true. If it is 0, end the program. So this is similar to a previous sample, right? If it is 0, end the program, that means we're going to write a break statement. So, or before we start, what is a composite number? In integers, if an integer is greater than 1, a number is composite. In integers greater than 1, a number is composite if it can be divided by integers other than 1 and itself. For example, 18 is a composite number because it can be divided by 2 other than 1 and itself. It can be divided by 2. And 1, how about 1? Is 1 a composite number? 1 can only be divided by 1, so probably 1 is not a composite number. 18 is a composite number. So if we have a number n, we have to try it out all the numbers between 1 to n. All the numbers between 2 to n minus 1 and check whether n can be divided by these numbers. If n can be divided by these numbers, that means n is a composite number. So first we have to read in this number from the inputs, right? So define a number first and read it in. And then we have to write our actual logic, determine whether number is a composite or not. Can it be divided by a number between 2 until n plus n minus 1 without any dividend? Think about it. To iterate through numbers from 2 to n minus 1, what can you use to help accomplish this? It sounds like we should use a for loop, right? Because the condition is fixed, is limited. We know exactly how many times you are going to loop. The number of loops is fixed. So repeatedly and limited number of repetition. If it's limited number of repetition, then we can use for loop. So first, define an integer and reading an integer. And then for 2 to number minus 1, we're going to check whether after division, whether remainder is 0, right? So if number can be divided by I wholly, then we print out true. That means it's a composite number. And right after you find this composite number, we're going to break out of this for loop because now we don't have to continue to try with the numbers behind anymore. Already we know it can be divided, it's a composite number. So we're going to break out of this for loop. Okay. And then if none of the 2 until number minus 1 match, right? Then we're going to print out false. That means this number is not a composite number. But then this is not enough. Think about that. If we print out true and then we break, and then next line will be false, then we print out false also. So we print out true and false at the same time. So it obviously is incorrect. We have to have some more control over this. So we can use some we can record, for example, we can use a variable to record which number, how many times we have loop. For example, we have a number I. And then here, before I print out false, we have to check if this I equal to number. That means does this loop run until the end of the loop? That means run until I equal to number. That means none of the numbers in between match. So if I equal to number, then we print out false. That means this number is not a composite number. So we use the variable I to determine the result of the loop execution. So this number I is to determine whether we have found the composite number successfully. If it's not found, then print out false. So actually, maybe not just I, or it can be a Boolean flag. So a Boolean flag initially is false. Let's say it's false. And then when you found a composite number, before we break, let's set F to true. Right? We set this Boolean flag true. So if F, let's say found, let's say F means found. So if found, if not found, then we print out false, right? If found, that means we found a composite number. Found is true. If not found, that means found is false, right? Not false means true. Only if true, we'll execute this. So if not found, we'll print out false. That means composite number is not found. And then, so this is the logic to check composite number. But then we haven't completed yet. We have to modify it to make it input repeatedly. How can we do so? Because we want to allow the user to enter the number repeatedly, right? So we can make use of the while loop because we don't know how many times the user is going to input the number. So in this scenario, it's best to use a while loop. So the while loop, the condition is always true, and it always allow user to enter the number. Always allow user to enter a number. And then once the user has entered a number, can execute our logic here to print out either true or false. This is to check the composite number. And then after that, remember there should be a break condition. Otherwise, this will be an infinite loop. It runs forever, you're always waiting for user to enter number. So we need to have a break condition. So in this case, we are going to, right after reading the number, we're going to add a condition. It's like, if number equal to 0, we're going to break. That means we're going to break off this while loop entirely. Okay. It's not, this break is for the while loop. It's not for a for loop. This break is for loop. This break has nothing to do with the while loop. Remember, break applies on the closest, the nearest for loop and while loop. So for this break, the closest for loop is this for. So it breaks out of this for, and the next line to be executed is this line. But for this loop, for this break, the closest while loop for it, the nearest parent while loop for it is this while loop. So it will break out of this while loop. And then there's a Minesweeper game. So we'll see this question in the homework session later. And then there's a small recap on operator. So first, assignment. Equal means we're going to assign the value on the right side. We assign 3 to a variable A. So we assign 3 to A. So, and then there's assignment after operation. That means, so A plus equal 1 means is the same as a equal a plus 1. And minus equal times equal divide equal is the same thing. Okay. It's a simplified version of a equal a plus 1 or a equal a minus 1. And then there's arithmetic operator, addition, subtraction, multiplication, division, modulus. Plus, minus, plus, plus, minus, minus. Minus, minus, plus, plus means is plus, plus mean a plus 1, something like increment by 1. Minus, minus means decrement by 1. And there is a difference between a plus plus and plus plus a. So if you can't recall it anymore, you can refer it to the previous slides or the previous lectures. And then there's greater than, lesser than, greater than or equal to, lesser than or equal to. And then there's equal equal. If x equal to y, then it's true. Otherwise, it's false. And then there's not equal to. So take note of this not. And so usually in programming, not is the exclamation mark, not equal. X not equal to y. It will be true if x is not equal to y. Otherwise, it will be false. Not. So this is not symbol. If x is a Boolean value, applying not in front of it will reverse its Boolean value. If it's true, you reverse it into false. If it's false, you make it into true. And then there's and so there's also an and condition. If x is true and y is true, then it is true. If either of them is false, then it's false. And also there's an or condition. For all condition, either of the x of y is true is enough to make it true. So if both x and y are false, then this calculated into false. And remember, relations and logical operators both return Boolean value. So what is logical operators? These are logical operators. And these are relation operation. These are relation operation. Greater, lesser, greater than, equal to. So these are relation and operation and logical operator. So this return Boolean values. So that's why we often use them in the condition part for our for loop or while loop. So they are being used in the condition part. And then there's some precedence of operator. So you can refer to the previous slides or refer to the previous lectures. We talked about this already. And then there's a debugging tips. So there's a debugging question. Using namespace standard integer main, integer I equal 1 while 1, if I equal 100 break I plus equal 2. So can you spot the issue here? Sure, this an infinite loop will happen. Why is that so? Because I is never equal to 100, right? So very be careful with your condition. Make sure that you can actually make sure that this condition can actually be executed, can actually be matched. So in this case, we initialize I to 1. And every time we're going to plus 2. That means I will always be an odd number. 1, like 1, 3, 5, 7. Always be an odd number. It will never be 100. So this will be an infinite loop, right? So also, if you can spot the issue, maybe you can try to print out something so that you know what happens inside a loop, or you can try a step-by-step debugging like what I have demonstrated just now. Yeah, this will never be executed because it plus 2, right? I initialize to 1 and it always plus 2. And we have infinite loop. So as a chapter recap, so for this chapter, we talk about while loop. While loop is very similar to for loop and when to use while loop. when you are not sure about your condition, your looping condition, you are not sure how many times you'll be executed, then it's best to use while loop. And then we talk about break. Break is for breaking out of the nearest parent loop. So break works for both for loop and while loop. Also, is a keyword in switch as well. Also, there's continue. So continue is to continue the next iteration of the loop, to continue to the start of the loop, is to start over again. It works for loop and while loop as well. And this is all about this chapter. Next chapter, we'll start to talk about some array. Because right now, we can, always when we are storing a variable, we can only store one number, right? What if we want to store a 100 numbers? How can we do so? So we need array for this. So next lecture, next week, we'll start to talk about array. So stay tuned next week. And let's rest for 5 minutes. 5 minutes later and 10:08, we'll start our exercise session. We'll go through some of the exercises about while loop, about while loop. So let's take a rest now for 5 minutes until 10:08. Hello guys, it's 10:08, so let's get started on this classroom exercise session. So let's go through some of the basic while loop syntax. So here we are required to loop through 1 to 10. How can we do so? It's very simple. First, define your variable I equal to 1. Okay. Then while I is lesser equal to 10, we're going to print out I. And every time before the while loop ends, remember to increase your I or update your I. So in this case, you want it to increase by 1. So I plus plus. Run it. So 1 to 10 will be printed out. Next. Next is to print out 197 until 2. So this is quite similar to for loop as well. Actually, for loop is more suitable for this scenario because you see we know exactly how many times it will repeat. We know the condition for it to repeat. So, but in this case, they want us to practice with while loop, right? So let's do it in while loop. So first, initialize I with 197, and then while I is greater than 1, print out I. And observe pattern here. The pattern here is all of them are off by 13. So print out I and then update your I, like minus it by 13. And then we run it, we print out 197 until 2. Submit it. Okay. So this is very similar to a previous problem. So as you can see, it's a very, very similar structure. So let's skip this. So here it's saying that design a program where the user repeatedly inputs an integer n until integer is a multiple of 7. Then display n is a multiple of 7 and the program's n. So in this case, already you have discussed in the course, right? So if you don't know how many times the user is going to input, then it's better to use a while loop. So in this case, for this while loop, inside a condition, write this as true. So that we always allow the user to enter a number. And then we're going to read in the number. Okay. After reading the number, we check whether the number is a multiple of 7. If it is a multiple of 7, then we print n is a multiple of 7. And then we want the program to end. How can we do so? Can make use of a break. By using a break, it breaks out of this while loop. And the next line to be executed will be line 27. And try run this. So if 9, if 3, if 0, 0 is a multiple of 7. Oh, it's true. 7 times 0 will be 0. So what if it's 14? 14 is a multiple of 7. So it breaks out of the while loop. And then there's a question that allow the user to repeatedly inputs a variable n. If n is the same as the random number, then display bingo and the program ends. So it's like this. Allow repeatedly inputs a variable number. So it sounds like it's better to use while loop, right? So it's correct. It's better to use a while loop and then allow a user to enter a number. If the number match the random number, let's say already the random number, the code for a random number is provided. So this is how you generate a random number. So we have an x. If n equal to x, the number that the user input is equal to x. Then print out bingo and then exit the while loop. Otherwise, ask the user to try again. You can print out, try again. 1, 5, 6. Okay, 6 is the answer. Let's get to the, oh, there's so many questions here. Basic continue syntax. So for this one, observe the following sequence and use a loop to display. So the sequence here is we always skip a multiple of 3. If a number is multiple of 3, we are not going to print it out. So we can look from I equal to 1 to from I equal to 1, while I is lesser than 100, we check if I is a multiple of 3. If it is a multiple of 3, immediately continue. Don't print the I out, right? Yeah. Please create a program that calculates the sum of all numbers between 0 and 99, excluding multiples of 3. For this case, we can look from 0 to 99 because we already know the condition for a loop and how many times the loop runs, right? So it runs from 0 to 99. So it's better to use a for structure here. So for I equal to 0 until 99, we wanted to skip multiple of 3, right? We want to add up all the sum, but we skip multiple of 3. So if it is a multiple of 3, continue. Go back to the start of the loop. Otherwise, we're going to continue. We're going to sum up all the total here. Sum up the total of the I. And at the end, print out the total. And this is an interesting question. Please follow these steps to design a Minesweeper game. First, allow a user to enter a number representing the mine's location, 1 to 100. The user must make 5 attempts. If they step on a mine, input number equals the mine's location, display bomb, and the game ends. If they do not step on the mine, they continue to try until all 5 attempts are exhausted. When all attempts are used up, display survive. That means first, we want the user to enter a number. And then after that, the user have 5 chance. We want to allow the user to enter 5 times. If what they enter is the same as the mine's location, then we print out bomb and the game ends. That means there should be a break here, right? Right. If they do not step on the mine, they continue to try until all 5 attempts are exhausted. So that means for this part, there should be a continue, right? When all attempts are used up, display survive. So if they have already made 5 guesses and they never step on a mine, then we display survive, and then we have to break out of the loop as well. So first, allow the user to enter the mine location. After that, the user have 5 attempts, right? So user has 5 attempts to guess the mine's location. So we can count it from 1 to 5. Max attempts is 5, 1 to 5. And every time after a loop, attempt plus plus. And the user have to make a guess. If what the user enter is equal to the mine location that he set previously, then bomb. End the game, can return 0. And if the user did not guess the find mine's location in 5 attempts, then after the for loop is executed, so he survived, right? So we're going to print out survive. Or you can actually use break here. If he step on the bomb, break out of the for loop, and then he doesn't survive, right? So now we actually have to check if boolean survive. If he step on the bomb, survive, it's false. And then this flag is very helpful. How can we make use of it? If he survive, That means he never stepped on a bomb. Then we print out survive. Right. If I run this, let's say the bomb is on 30. So I have 5 guesses. I guess first 1, 3, 10, 4, 30. Oh no, I stepped on a bomb. So it ended. What if still the bomb is at 30? 1, 2, 3, 4, 5. I survive. So there is a part 2 of this game. Part 2 is quite similar. First, allow a user to enter a number presenting a mine's location. And then the user must make 5 attempts. If they step on a mine, display bomb and return to the first step. So the difference is here. If they step on a bomb, we didn't exit the game. We're going to return to a first step. So return to a first step is something like a continue, right? If they do not step on the mine, they continue to try until all 5 attempts are exhausted. So this is the same as the previous question. When all attempts are used up, display survive and return a first step. So this is also different. When all attempts are used up, we have to return to a first step. That means to allow the user to make a guess again, to allow a user to enter the mine's location and make the guess again. And then only when the user is entering 0, then the program ends. So that means for this case, we don't know how many times these games will be played. This game might be played many times until a user enters 0. So for this case, it's best to use while loop, right, compared to for loop. So here, we can define a while loop. And then inside this while loop, we're going to read in a mine location. If the mine location equals 0, we have to break out of this while loop, because if 0, that means the program should end. And the user have 5 attempts to guess, right? So we look for 5 times. If the user step on the mine, we print bomb and then we break out of this for loop. And then after this for loop, there is a checking to check whether the user have stepped on the mine. If he had never stepped on the mine, then we print survive. And then after that, remember we are inside the while loop, right? We are inside the while loop. So after that, we'll ask the user to enter mine location again to restart the game over again until the user enters 0. 0 means he wanted to quit the game. And then there's some homework question as well. It is known that the format of a while loop is while condition and then the curly braces, where the condition results in a Boolean value. The following settings for the while loop syntax are all legal, but which one will not print high? While 1 prints out high, this is correct. While a equal to 1, prints out high. So this also works. So this is a very bad practice to write like this. So what happened here probably is, as far as what I can remember, what happened here is you are assigning 1 to A, right? And then after that, this expression return 1 to wow. So this will be a true. And how about this? A equal to 2, while A equal 1 prints out high. This is not correct because A is 2, right? So this calculated to false and thus high will never be printed out. How about this? While A prints out high. A is 2. A is 2. So if 2 converted into Boolean value, it will be true. So this height will be printed out. How about this? A equal 2 while A minus 2. A minus 2 will be 0. 0 will be converted into false. So if false, this won't be executed. So height won't be printed out. Based on the following program, which statement should be added to allow it to break out of the loop? A equals 0 while A lesser equal to 10 prints out height. So there is an infinite loop here, right? Because A is never updated. A is always equal to 0, always lesser equal to 10. So in order to make it break out of the loop, you can use an A++. So A++ inside a loop. So until when A equal to 11, it breaks out of the loop. Based on the following program, what statement should be added to the underlying to print height 20 times? A lesser than 10. A initialize 0 while A lesser than 10 prints out height. We want to print out 20 times, right? It's like 100 divided by 20 would be 5. So every time we increase it by 5, right? So every time inside a loop, we increase A by 5. And then this is a simple like pattern question. Now we go through it many times already. And for this case, it's better for this kind of scenarios. It's better to use a for loop, right? As we have discussed in the course, in the lecture, because already we know how many times it will repeat. We know the start and end condition, so it's best to use a for loop. But this is a while training, so I use a while. But anyways, you can write it using for loop. Integer a equal 100, while a greater equal to 1, a minus equal 3. And then prints out a. Yeah, it prints out 100 to 1. Use a while loop to find all the factors of 100 and display them. Then, how to find a factors of 100? So you can look through 2 until 99. If they can divide, if they can fully divide 100, that means they are a factor of it, right? So we can look from I, while I lesser equal to number, while I lesser than 100. If 100 can be fully divided by I, that means I is a factor, and I++. Because it's inside a while loop, so remember I++. For this case also, it's best to use a for loop, right? For I equal 1, yeah, because we know exactly the repeat condition, so it's better to use a for loop. Design a program with the following functionality. The user enters an integer n and the program outputs the number of digits in that integer. Oh, this is a very fun question. So if you are given 9453, so they have 4 digits. Now your task is to return 4 because there are 4 digits. How can you do so? So this is actually a math question. Every time you can make use of while loop because given this input, we don't know exactly how many times you are going to execute the logic. So every time we are going to divide by 10. After divide by 10, you remove a digit, right? 9453 divided by 10 become 945, right? You remove a digit. 945 divided by 10, you get 94. remove a digit again. So every time if you are able to remove a digit, the digits count +1. And the loop condition is your number has to be greater than 0, right? For example, 9, if for 9 divided by 10, it will return 0. That means it should be the end of the loop. The end have to be greater than 0. So given a number like 9453, we have a loop to always divide it by 10. Every time we are able to divide it by 10, we increase the digit count. And then while it is still greater than 0, we're going to divide it until it's equal to 0. And then when it is equal to 0, we print out its digit count. So 9453, print out 4. How about 2, 3? 3 print out 1 because there's only one digit. How about 1, 2, 3, 4, 5, 6, 7, 8, 9? It prints out 9. Yeah, this is a very, very fun question. And please create a program with the following functionality. The user can repeatedly enter an integer n until they enter 0. The program should sum all the enter integer except for those that are multiple of 3s and then n. This is very similar to the sample in the lecture slides, right? So it should be a while loop because we don't know how many times the user is going to enter a digit until it meets a 0, then break out of this loop. And then we can do some extra processing for it. And then there is the last question. This is a fun question. You have to, the programming side is not hard at all. The harder part is to observe the pattern by yourself. Let's say, so it's asking you to calculate how many squares are in an n times n grid. For example, 2 times 2 grid contains 5 squares. So 2 times 2 grid got 1 square, 2 square, 3 the 3 square, 4 square, and then it as a whole is a square as well. So there are 5 squares. If I give you any number of n, like 3 times 3 grid, how many squares are there? 1 times 1 grid, how many squares are there? So write a program for me. So for this case, for this question, we just have to read in the n, and then we print out how many squares are there. But what is the pattern for the number of squares? So this is left as an exercise for you. This is a very fun exercise. So if you have access to these problem sets, you can try it out by yourself. Okay. And this would be the end of today's class. Next week, we will start talking about array. An array is something very useful for you to store a lot of data. And thank you all for listening. See you guys next week. Bye-bye.